Hey everyone, today we're going to be talking about inequalities, and I think the best way to understand what an inequality is to look at how it compares to an equation. So you can see here I have two columns. I have an inequality column with 3 examples of inequalities, and then my equation column has just one example of an equation. When we get an equation, this is what we're more familiar with. We're basically saying that the answer is anything that you could put in there for x to make the statement true. In this case, there's only one single number that you could put in for x to make it true, and that would be 3. So an equation, especially the ones we've been seeing, would have one answer. When you get to more complicated math, there may be more than one answer, but for what we're studying right now, there's one answer for equations. Inequalities, on the other hand, have a range of answers. If you look at the first inequality, it means x is less than 3. You may have learned in the past that the inequality sign is kind of like an alligator mouth. So it's like a mouth that's eating the 3. The wider part is facing the 3, which means the 3 is bigger. And we always read inequalities left to right. So we would say x first, and then we say the less than symbol, and then we say 3. So x is less than 3 is how you read it out loud. Now, what numbers make that true? What could I put instead of x to make it true? I could put a 1 there. 1 is less than 3. I could put a 0 there. I could put a -10 there. I could put a 2 there. There's a long list of numbers that I could put in that spot, and it would be a true statement. So we're going to talk a little bit about how you can display that information to communicate to your audience what numbers work. Second one is less than or equal to 3. When you have the little line underneath it, it means or equal to. So all of my numbers from the previous example work. 1 is less than 3, 0 is less than 3, -10 is less than 3, 2 is less than 3, and I could add other numbers as well. But the or equal to means that 3 is also an option. So numbers that are less than or equal to 3 would be 3 itself, or all of the other numbers that are less than 3. The symbol itself is like combining a less than symbol and an equal symbol. When you combine these two symbols, you get less than or equal to. The last type of inequality that we're not going to see too often, but we'll see once in a while, is just the not equal to symbol. This last one means x is not equal to 3. So what are some numbers that are not equal to 3? Well, it's a lot of numbers from our list before. 1, 0, -2, 10, -10 and 2, those all work. We could also go bigger. We could go 5 or 100 or 150. For any of these examples, fractions or decimals work as well. So inequalities have a huge range of solutions. I've only listed out a couple of examples, but you could come up with more examples for each of these inequalities as well. Equations only have one solution, at least the type that we're studying. So what we're going to do is try some of the problems on this page, which ask us to make graphs, which are going to be in the form of number lines here for all of these questions. So you can see what I've done for each problem is I've drawn a number line with 0 in the middle. And you can use your scissors tool to copy and paste that. So pause the video and get your page set up with all of these number lines, please. Unpause when you're ready to go. All right, hopefully you've paused the video and you've unpaused, and you have number lines ready and waiting for you in each of these problems. We have 0 in the middle. That just kind of communicates to our audience where on the number line these numbers are located. So for each of these examples, what we're going to do is start by plotting the number in the problem. So the first one says x is not equal to 4. So that means the first thing we're going to do is we're going to just kind of estimate where 4 would be. You don't have to put any of the other numbers in there. Basically, you just need it on the right side of 0, not the left side where the negative numbers go. X is not equal to 0. What we're going to do here now is put an open circle on the 4. This means that 4 is not eligible to be an answer because x is not allowed to equal 4. Let's see what other sorts of numbers work for this. do the numbers on this side of 4 work? So that would be like if we put a 5 in, is 5 not equal to 4? Yep, that's true. How about if we put a 30 in? Is 30 not equal to 4? Yep, that's true as well. So the arrow is indicating that any number on this side of 4 is a valid answer, and we're not going to plot them in. We're not going to waste our time. We're just going to assume that we know 10 is here, 100's here, 1,000's here, any number in between, 30's here. All of these numbers are valid solutions to x is not equal to 4. So we can have an arrow going that way. What about the numbers less than 4? Are those numbers not equal to 4? So would it be fair to also have an arrow going this way? So that would mean a number like 0 could work. Is 0 not equal to 4? Yep. How about -1/2? Is -1/2 not equal to 4? Yep, that works too. So what this graph is showing us is that the open circle on 4 tells us that 4 does not work for the equation. We cannot say 4 is not equal to 4. Not allowed. But the arrows show us all the numbers that do work for the equation. So it's a way of modeling this inequality so that your audience knows that all the numbers located here and all the numbers located here work. All right, let's take a look at the next one. So this one says x is greater than or equal to 2. And I have all the symbols defined up at the top here, right in this area, if you want to remember what the symbols are. So if it's a symbol pointing in this direction, it means greater than. The line underneath it means or equal to. So x is greater than or equal to 2. The first thing we want to do is put the 2 in there. Just got to put it on the correct side of 0. It doesn't really matter how far out you have it. And then I want to decide, do I want an open circle or a closed circle? Well, I made a little chart for you here to help you remember that. Open circle is for less than, greater than, or not equal to. Closed circle is for less than or equal to, greater than or equal to, or equal to. So any of the symbols that have an equal to sign, you color in the circle. So we are going to color in the circle on this one. That means that 2 is a possible answer. It's colored in to say that, yes, this is an answer that works. For an inequality like this, you would only have one of the 2 arrows. So we have to decide if we want all the numbers bigger than 2 or all the numbers smaller than 2. Let's take a look. If I put a 0 there, is that true? 0 is greater than or equal to 2. No, that's not true. So I don't think the number smaller than 2 will work. What if I test it out with a 5 instead, bigger than 2? 5 is greater than or equal to 2. Yes, that does work. So I want the arrow pointing in the direction of where the 5 is. These are all the numbers that are greater than or equal to 2. So these are the numbers that are solutions to the inequality. The numbers on the left side are not solutions to the inequality. They're less than 2. We don't want them. And since the circle is colored in, that means 2 is an answer. 2 is greater than or equal to 2 is valid. That is correct because of the or equal to part. Let's keep trying these. So the next one, x is less than 7. So first I want to get the 7 in. Just kind of estimate where the 7 goes. Doesn't really matter how far away it is. Since it doesn't have the equal to underline, it doesn't have this little thing, it's going to be an open circle because 7's not an answer. It's like a bubble saying, don't touch the 7, it's not an answer. Now I have to decide which way the arrow points. It says x is less than 7. So I want numbers that are less than 7. So it goes this way. So if you're looking up at the chart at the top with the names of the symbols, it kind of gives you a clue of which way the symbols point. All right, the next one, the x is on the right. So the first thing that we're going to do is flip it so the x is on the left. That's going to make a trick that I'm going to show you later help you solve these problems. So we have to carefully flip everything. We have to flip the x and the 6, and then we have to flip the symbol. So the alligator mouth is eating the 6. So that's our new inequality. Now C and D are pretty similar. Pause the video and see if you can graph D on the number line. Unpause when you're ready to go over it. All right, hopefully you're ready to go over it. So I put my 6 about there, and I want an open circle because it's not equal to 6. And then I want it pointing left, less than, all the numbers that are smaller than 6. I'm going to show you guys a trick now. This trick only works when X is on the left side, which is why I had you flip that one. If you look at the symbols, you can turn the symbol into an arrow. So I'm just making each of these into an arrow. And then that arrow tells you which way the arrow in the inequality is going to point. B's arrow points to the right, and that's how the arrow in the picture looks in our answer. C's arrow points to the left, and when we graphed it, our arrow pointed to the left. D's arrow also pointed to the left, and when we graphed it, our arrow pointed to the left. So that's a really nice trick so you don't have to think about it so much. But it only works if X is on the left side, which is why I had you flip question D. All right. I'm going to have you guys try E through I and then come back when you're done with those. Pause the video, try E through I. All right. Hopefully you are done with those. And I'm going to go over a couple of the answers now. So on E, X is greater than 2. So I want to put a 2 in there. It's an open circle because there's no equal to part of this. There's no equal sign underline. And then if I use my trick, it's pointing this way. That tells me the arrow has to point that way too. So the actual inequality symbol shows me which way to draw my arrow in the picture. So I want all the numbers that are greater than 2. And then F, X is greater than or equal to -4. So here's my -4. It just has to be on the left side of 0. Doesn't matter how far out it is. Since it does have the or equal to part to it, it has that little underline. That means I color in my circle. You have to make it so the reader, your audience, can clearly see that you've colored it in. If somebody who's grading your work can't tell if you've colored it in or not, you're going to get it wrong. So make your circles nice and big and make it clear if they're colored in or not. And then if I use my trick, the inequality sign points this way. So X is greater than or equal to -4. All right. So I'm going to leave G, H, and I without going over those answers. But I will go through J with you. So J just has a double inequality for us to graph. It's not really any harder. It's just double the amount of work, really. So I have 2 of them. I need to get 2 done, and I need to get 9 done. For 2, I need a closed circle because that one has the equal sign underline. For 9, I need an open circle because it does not have the underline. 9 is not a possible answer, but 2 is an answer. If I look at the inequality symbol, it's like an arrow pointing this way on the 2. So I'm going to draw an arrow this way. And then the other inequality symbol for the 9 is an arrow pointing this way. So I'm going to draw an arrow pointing this way. So it's just a double one. It's just 2 on 1 graph, but it doesn't really make it any different. So the numbers that would work for this, that would be like an answer, would be all the negative numbers. So like -5 works, -1 works, then 0 works, 1 and 2 work. But numbers that do not work would be the numbers between 2 and 9. So like 3 does not work, 4, 5, 6, 7, 8 do not work. And 9 doesn't work either because it was an open circle. But the numbers bigger than 9 do work. So 10 works, 10.5 works, fractions and decimals work. 20 works, and so on. So that's some inequality practice with graphing. Make sure that you have the whole page done. The other thing we're going to go over are some of these expressions and matching them up with the different signs that they could mean. So I want to remind you what each of these symbols mean, and I think you should copy them down onto your page as well. So the first one means less than. The second one means greater than. The third one means less than or equal to. And the last one means greater than or equal to. A lot of people have trouble understanding that the signs actually have these names and that you can't just pronounce them either way. But we always are pretending we're reading it left to right. So if there was like an X here and a 10 here, you would say X is less than 10 because you're reading it left to right. So that's why it's called less than. So what we're going to do is we're going to look at each of these expressions and figure out which symbol they match up with. So the first symbol, the first expression is at least. So at least means the same thing as one of these. At least maybe means less than, or maybe it means greater than, maybe it means less than or equal to, or maybe it means greater than or equal to. What I like to do to figure this out is pick a random number. And since I already used 10, I'm going to use 10 again. I'm going to say at least 10 is my new thing that I'm thinking of. And then I'm going to set this up with 10s in all of the expressions. 10 is a random number that I picked. I could have picked any number in the world. So think to yourself, what are some numbers that are at least 10? First of all, is 10 at least 10? Yes. So 10 is an example of an answer. 11 is at least 10. 12, 13, and so on. So it looks like the numbers I'm looking for would be exactly 10 or numbers that are bigger than 10. So which one of these would give me exactly 10 or numbers that are bigger than 10? Well, exactly 10 means that these two cannot be answers. Now I want the numbers that are bigger than 10. That's going to be this one, greater than or equal to. So I can get rid of these X's. Remember, 10 is a random number I picked. I could have picked anything. Now I'm going to try the next one, at most. Maybe this time I'll try a random number of 6. Then I have to change all of these to 6s. I'm changing numbers just to demonstrate that it doesn't matter what number you pick. They're just examples. At most 6. Well, first of all, is 6 at most 6? Yes, so 6 works. Now I have to decide if I want numbers that are bigger than 6 or smaller than 6. Is 7 at most 6? No, 7's too big. Is 5 at most 6? Yes. So that means I want all the numbers that are smaller than 6. And I want 6 as well. Since 6 works, it narrows it down to these two. It has to be one of them with equal to. And I want numbers that are less than or equal to 6. If you think you've got the hang of it, pause the video and try the rest of these, and then come back to watch at the end for me to go over answers. If you don't think you've gotten the hang of it, you can keep watching. I'm going to stick with 6 as my answer, as my example, just because I don't want to have to keep redoing all my numbers. How about no more than 6? Is 6 no more than 6? Yes, it is. Because they're basically saying it can't be more than 6. So the number itself works. Now, do I want numbers that are bigger than or smaller than? Let's see. Is 10 no more than 6? No, that wouldn't work. That is more than 6. So 5 is no more than 6. So again, I want numbers that are smaller than 6 or equal to 6. Since 6 works, it's going to be one of these two. And I want less than or equal to. So no more than and at most mean the same thing. How about no less than? So no less than 6. That means it could be 6, but it's not allowed to be less than 6. So 6 works. But if it's not allowed to be less than 6, then it has to be the numbers that are bigger than 6. So like 7, 8, and 9. So greater than or equal to. All right, we'll keep going. What are some numbers that are up to 6? Well, 1 is up to 6, 2, 3, 4, 5, is 6 up to 6? Yeah, I think they're saying that like 6 is the maximum of what we could have. So I want less than or equal to, because I put numbers that are less than 6 or equal to 6. In excess of or exceeding 6. All right, so I don't think 6 exceeds itself. So I think I have to go with numbers that are bigger than 6. 7, 8, 9, 10, and so on. So this would be greater than. How about below 6? Well, below 6 makes me think it can't be 6 itself. But I think it could be numbers that are less than 6. So like 1, 2, 3, 4, 5. Or anything less than 1. Any negatives would work too. So that's going to be less than. All right, we're over halfway done. If you want to pause the video now and try the rest on your own and then come back, you're welcome to do that. Or if you're totally stuck, just keep watching. Smaller than 6. Well, to me, smaller than 6 just means the exact same thing as less than 6. It can't be 6. It could be any number less than it. I think I'm going to change up my number. I'm getting kind of sick of using 6 as an example. I think I'm going to go back to 10. You could use any number for these. This is just how I like to think about it. How about larger than 10? So larger than 10, I don't think it could be 10. So that eliminates these two because those would be the ones that would be equal to 10. But I think it could be this one. All the ones that are greater than 10. It can't be less than 10. Made that check a little bit too big. Less than 10. Well, hopefully you've realized less than 10 must mean less than. And greater than must mean greater than. Now, maximum and minimum are tricky again. So maximum of 10, let's see, is 1 a maximum of 10? Yep, 1 will work. So I think the numbers that are smaller than 10 are going to work. 2 is a maximum of 10. Yep, all the way up. Now the question is 10 a maximum of 10? You can have a maximum of 10 donuts. Yeah, so 10 works. So the number itself works, which means it's going to be one of these two. And I want the ones that are less than or equal to. So maximum makes you think of big numbers, but it's actually referring to the numbers that are smaller than it. And I bet minimum is going to be just the opposite. A minimum of 10. So you need a minimum of 10 points. So I think 10 will work there. And will 1 work? Is 1 a minimum of 10? No, you need 10 or more. So 10, 11, 12, and so on. Since 10 works, it's going to be one of these two. So greater. Greater than or equal to. What I'm going to do now is erase all of my little notes from when I was experimenting. And I'm going to leave the page like this. What I highly recommend is taking a screenshot of this because you are going to be, let me get rid of these two. Because you are going to be seeing all of these words and you do not want to have to memorize all of these expressions. But if you use this page as like a note sheet for yourself, a sheet of the terms, you can put this screenshot on any of our homework pages and use it to help you practice. So thank you guys for watching.